Hello again. In this section of the lecture, we're going to be talking about joints. This is the last part of the lecture on the skeletal system that we'll be talking about. So let's talk a little bit about joints. So in general, joints are where bones come together. And of course, the reason we have these joints is so that we can move and carry out the functions that we need to. If we didn't have joints, because of the rigidness of the bones, we wouldn't be able to move around. We call this articulation. Articulation is where two bones meet, and so your skeleton is what we'd call articulated. You can have a disarticulated skeleton, which would just be a pile of bones, none of them hooked together by joints. So joints are very important, and so we're going to learn a little bit about the classification of joints, and then we'll also look at what can possibly go wrong with joints as well. So joints are classified in a couple of ways. First of all, we can classify them functionally, and we can also classify them structurally. So both what they do and what they look like. So let's take a look at each of these here. First of all, the functional classification of joints. We can put all of the joints in our body into three categories depending on their function. First, we have synarthroses. These are the immovable joints. So these are joints where bones come together, but there's no movement between those bones. Some good examples of this would be the bones in your skull. So your skull is made up of a number of bones, and where those bones come together, we have joints, and we call those sutures. And we'll see some more about that just here in a minute, but those are synarthroses. Those joints do not move. We have amphiarthroses. These are slightly movable joints. And then we have diarthroses, and these are freely movable joints. So some joints that fit into diarthroses would be the joints of our limbs. So they are highly movable. And so we go from joints that are highly movable, such as the joints of our limbs, down to non-movable, but then we have some in between. So next, let's look at the structural classification of joints. We have three structural classifications. We have fibrous joints. So these structural classifications can be joined together with the functional classifications. For example, fibrous joints are usually going to be synarthrosic joints. So they're generally non-movable joints. Next, we have cartilaginous joints. And these can either be synarthrosis, or they may also be amphiarthrosis. And then we have synovial joints, and synovial joints are generally going to be diarthrosic joints. So they're going to be movable joints. So let's look at each of these a little bit more. Fibrous joints. So the joints are connected together with fibrous tissue. Some examples of this would be sutures, as we talked about just briefly just a second ago. Sutures, these are the type of joint you find in your skull, where two bones come together, and they're connected together by this fibrous tissue. So these are synarthrosic. They do not move at all. All right. Then there's a special type of fibrous joints called syndesmoses, and these allow a little bit more movement than the sutures, such as the ones in your skull, but they're still mostly basically immovable joints, and we find these at the distal end of the tibia and fibula. So here's some pictures showing this here. Here we have the sutures. So notice how these sutures look. So it's kind of like a jagged edge here connected together, all in this area, in this joint. All the blue area there is going to be your fibrous tissue holding those two bones together. Okay, we also have over here the tibia and the fibula, and this is the distal end, remember? So distal means is farther away from the body. So this is going to articulate down here. This is going to articulate with the bones of the foot. And here we have another fibrous joint. So those are examples of fibrous joints. Again, generally going to be synarthrotic joints. Then we have cartilaginous joints. And these are bones that are connected together by cartilage. That's where they get their name. And some examples here are in the pubic bone and also in the invertebral joints. So our vertebrae are connected together by cartilage. We have this fibrocartilage. So remember, we had some different types of cartilage. Before we were talking about hyaline cartilage, and hyaline cartilage is that type of cartilage that our skeleton is initially made of, and then it's replaced by bone as we age. And fibrocartilage is another type of cartilage, and that's the type of cartilage found. One of the main places it's found is in the invertebral discs that you're familiar with. So if you ever heard of someone slipping a disc, that's their fibrocartilage. So these both act as a cushion for the vertebrae, but also it helps connect them together. So these have more movement than the fibrous joints. So these are going to be amphiarthrotic, or they may be synarthrotic. Another place we have where our ribs connect to our sternum. So we have a little bit of cartilage here as well, holding those ribs to our sternum. And so this is an example here. So when someone does CPR, inevitably, those ribs are going to detach from the sternum. So we have here this cartilage is holding these bones. So you're not actually cracking bones necessarily when you're doing CPR, but this cartilage can become detached from the sternum. And then also, this is a picture of the pubic bone here. So we have the fibrocartilage connecting the two sides of the pubic bone together. And this allows for some movement as well, especially in females. So as the baby is going through the birth canal, it has to fit through this hole in the pubic bone. And so this joint here allows for some widening, for some movement. So the baby is able to get through that opening, and the delivery is able to happen. So these are examples of cartilaginous joints. And then there's synovial joints. So synovial joints are characterized by the synovial membrane. So the reason we call them synovial joints is because they have a synovial membrane. So in a past lecture, we talked about the types of membranes. We talked about epithelial membranes, and then we also talked about a connective tissue membrane, and there's one type of connective tissue membrane, and that was synovial membrane. So the synovial membrane is made of connective tissue, and it's found around joints, and it secretes a fluid, a synovial fluid, that's going to go into that joint cavity and allows for, keeps the joint from having friction and rubbing against each other so that our joints are able to move and they're not painful. So let's look at some synovial joints here. So some places we find synovial joints are where our limbs come together. So in this picture here, we have our humerus, which is our arm bone, articulating with the scapula. And in here, we have this synovial joint. So the blue here is representing that the joint there. And so this joint is characterized by articular cartilage. So as we talked about before, on the ends of all our bones here, we're going to have some articular cartilage. And so it'll be on the end of the humerus, and then we'd have some articular cartilage over here as well. Then we have a little fibrous membrane, including a synovial membrane, fibrous tissue and a synovial membrane surrounding that joint there. And then inside this joint, the synovial membrane is going to be producing fluid and putting it into that joint. Here we have the humerus. Over here we have the humerus and the ulna. Also in our arm, we have articular cartilage. We have this articulation here. We have a synovial joint, and then also in our hands. So all of these very movable joints of our limbs are going to be synovial. So let's look at a synovial joint here. So we've already seen the articular cartilage. In the next slide here, we're going to look at the fibrous capsule that's surrounding that joint. We've talked a little bit about the synovial fluid. And then there's also ligaments. Remember, ligaments connect bone to bone, and so we have ligaments associated with this joint as well. And then we also have a few other things that are associated with synovial joints. First one is called the bursae. And these are little discs, fluid-filled discs. And they line the synovial membranes, they have fluid inside, and they act as this little cushion. And we'll see them in this next slide here. So they're separate from the joint, but they keep the bones from hitting each other and tendons from rubbing against bones. They help to keep everything from rubbing against one another so that our joints move freely. Then we also have tendon sheaths. So we have tendons coming through or around these joints, and as we'll see when we talk about the muscular system, muscles cross joints, and that's what allow our muscles to move our bones, move our body. And so as they cross these joints, we're going to have these tendons that are attaching these muscles to our bones, and so these tendons are going to be coming across these joints. So there's this tendon sheath around the tendon, and it's very similar to a bursae in that it's kind of like this lining. It wraps around the tendon, and it has fluid associated with it as well to protect that tendon from the friction associated with the joint. So let's look at this picture here, and we can see all these things here. So first of all, let's take a look at the joint. So here we have the humerus coming up, the bone. And then here on the end of the bone, we have our blue articular cartilage, and I'm making it red now. There's our articular cartilage on the end of the bones. Here's our articular cartilage here on the scapula as well. So the ends of the bones are covered by this articular cartilage. Now over here, I'm going to show you the fibrous tissue. So the articular cartilage is only on the end of the bones. It doesn't connect around. So we have this fibrous cartilage here that's surrounding this joint and making it a enclosed area. So this is totally closed in, and then on the very inside we have this synovial membrane, our connective tissue membrane, that's going to produce that synovial fluid. So the synovial membrane here, and there's going to be one on the other side of the joint as well, is producing fluid and putting it into this space. So the bones are not actually coming in contact with each other. Remember, fluid cannot be compressed, or when it is compressed, when you try to compress fluid, it doesn't change shape. When you compress gas, for example, if you take a balloon, you can squish that balloon, you can compress that gas down to a smaller volume. But fluid you can't do that with. So this fluid, because it's enclosed space, as you put pressure on this, it's gonna stay the same volume, and so these bones aren't going to come in contact with each other. For some reason, something happens to that fluid, then these bones will come in contact and can start scraping against each other. That would be very painful. So all of this is to keep those bones from coming in contact and allowing for easy joint movement. Up here we have our bursa, the singular of the bursae being plural. And notice it's just this little fluid-filled, it's kind of like a little pillow. So the bone up here, the scapula up here, can sit on top of that bursa, and it's not going to come in contact with the bone. And then here we have a tendon. So notice this tendon, because this is the bicep muscle. The bicep is associated with the humerus bone, and so this tendon is attaching the bicep to the other bone that it's going to be that's going to allow for this movement. So on the other side of the bicep is going to be attached to sorry, let me fix that. It's going to be attached to the forearm that allows you to pull your forearm up, but the bicep also attaches across this joint here as well in order to allow you to lift up your arm as well. So because this tendon is coming around this joint, it has this tendon sheath. So this green sheath here, notice how it wraps around it. It's filled with fluid, and it acts as this little cushion here so that joint can move freely. And so the tendon's not going to bump against the bones. One last thing while we're on this slide, if this was a young child here, This would be the epiphyseal plate here. You can see that area there, and that would be hyaline cartilage. So this would actually be an example of a cartilaginous joint. So this is cartilage, and it's hooking the lower part of the bone to this top part of the bone. And so this would be an example of a cartilaginous joint, but this joint would not be movable. So the epiphyseal plate doesn't allow for any movement, so that'd be a synarthrotic cartilaginous joint. So that's another example there. So here we have a synovial joint, here we have a cartilaginous joint. Synovial is going to be diarthrotic, and this one here is going to be synarthrotic. Then, of course, depending on where that joint is, these different joints allow for different movements. So the way the bones come together allow for the movement. So we have a few different types of joints that can occur. Some that you're most familiar with would be the hinge joint. So this works just like a hinge, and this is found throughout our body. For example, our forearm, our humerus, our radius, and our ulna, that allows us to move our arm up and down. That's a hinge joint. So the movement is only forward and backward. So it can't go necessarily side. It can't go side to side. We can twist our forearm, but that's a different joint associated there. So lifting our forearm up, putting it down, that's going to be a hinge joint. We also have a pivot joint. That's going to be our forearm. So as our forearm is able to twist around, that's going to be a pivot joint. It's pivoting around. And when you look at the bones of your skeleton in that lab, you can see how these bones attach together to make this little pivot and make that possible. One that you're maybe not quite as familiar with would be a plane joint. So a plane joint is the way it comes together. It allows for movement. Basically, it can twist, it can move from side to side, it can move forward and backward. This allows the bones of our wrists, allows them to be highly movable. We also have a few other types of joints. Maybe the most famous would be our ball and socket joint. Allows for movement in all directions. This is a very versatile joint, found in our shoulder and also in our hip, but this is also a joint that's very easy to hurt because it's so highly movable. The articulation is more loose, and a number of bones come into this area here, and so it's easy to damage the ball and socket joints. We have a saddle joint. And this is just like a saddle. So if this is just like you sitting on a horse, you're basically able to move side to side. And then the joint below can move forward and backward just a little bit. And this is where this is going to be some of the bones of our fingers. And then we also have a condyloid joint that allows for a lot of movement in our fingers as well. So these are different ways that the bones come together and our joints come together to allow for different movements.